Well, we've seen some excellent examples of cultural heritage mapping applications today, and I will try to situate many of the things discussed already by many presenters within an overview of the current research environment and the new issues that are being created. So in most cases, I think most of the participants would agree, mapping cultural heritage and building the necessary web infrastructure involves significant effort. Usually, heritage data mapping is not simply a digitization procedure. Rather, it is more of a datafication or a data building process, meaning that we are actually processing static data into new spatially aware information. In a sense, mapping can be considered as another way to think or build knowledge about our data, how they can be stored in a database, and represented on a map. This usually involves cross-disciplinary teams, as we've seen many times today, that can combine domain awareness, that is knowledge of the past, and technical skills, that is GIS, cartography, and a bit of coding. Applications can be built using various infrastructure solutions and usually require substantial effort to keep up to date. In the end, after a long process of data thinking and GIS experimenting, the effort materializes into a mapping application. We managed to build it. Now what? Usually, completing a mapping isn't as simple as it seems. There are always opportunities to search for new content that can expand both the spatial and temporal coverage of our mappings. We can search for data outside the limits of our initial boundaries or try to fill in blanks in space and time. We can even include data of various scales. In other cases, we can expand the thematic coverage using additional sources or media. Of course, adding new or more data types creates functionality considerations. 3D models need 3D visualization. Temporal data need temporal tools, while too much information needs visualization and infographic solutions to facilitate seamless navigation. To illustrate the argument, I include here a distant view of the Mapping Ancient Athens platform dataset, where you can see both the project's limits in relation to the city of Athens, as well as the data density differences within this boundary. If we move closer, similar observations can be made with respect to the chronological distribution of locations. In both cases, additional data can expand the informational capacity of the platform. This is something that you are already having as a future plan. Data gaps and additional content can be pursued in existing archives, including both paper-based or digitized documents. This can include personal archives from the excavators, newspaper reporting, sketches and photos, as well as other audiovisual material. New 3D content can also be included in mapping environments to foster a better understanding of material remains that may be removed, repaired, or otherwise get hidden. In terms of functionality extension, we have the example in the research project Museum Topos, where the architectural and geometrical documentation of buildings is combined with the geolocation of cultural practices within traditional settlements in the Aegean. This all gets linked into a GIS portal to explore the elements that contribute to a sense of place. Using heat maps, the density of historical buildings and activity areas are combined, while via the integration of the Session platform, 3D models of buildings can be accessed and examined for their architectural details in their original position. The existence of different thematic mapping platforms means that in many cases there are maybe many overlaps that can be exploited through the combination of the data. Larger data pools may be a lot more informative and lead to the investigation of new associations. Obviously, this is not straightforward, as there are many difficulties in aligning data that may have been structured in different ways or with different levels of detail. However, there have been recent calls for the creation of a spatial data infrastructure, or SDI, for cultural heritage spatial data that could render data from different sources as interoperable. An SDI provides a base collection of technologies for spatial data discovery for users and providers within the academia, the government, the commercial, the non-profit sectors, and the public in general. Of course, such a process requires additional work on interoperable data models and appropriate semantic structures. To provide an example of the potential, something that Yannis expressed earlier, the combination of rescue excavation data, listed heritage architecture, and crowdsourced documentation for undesignated pre-war buildings in Athens may provide novel insights into the archaeological capacity and the evolution of the modern urban settings. One needs only to combine things from mapping ancient Athens, the archaeological cadastre, and monumental doc Athens platform, and potential overlaps or dissociations in space and time may be revealed and studied using standard GIS query tools. This is a major point to be made. The informational capacity of mapping platforms provides new research opportunities. What can we do with a map data? Identify spatial patterns, understand potential data buyers, reveal associations. In many ways, mapping platforms contain data that, when employed alongside a broad range of environmental, topographical, or other historical datasets, can create research opportunities, be exploited during development works, or inform heritage monitoring and decision-making. In an example from the city of Patras, the mapping of archaeological and non-archaeological excavation interventions allowed the creation of an archaeological sensitivity map using Voronoi tessellation methods. Not only it was possible to estimate the extent of potential archaeology, but also predict the potential depth of the archaeological deposit. This sort of archaeological predictive models can inform the mitigation of preventive and emergency archaeological interventions, lead to economic value for developers, and facilitate improved decision-making for heritage management services. In addition, the informational content of cultural heritage mapping efforts can be harvested and reused in further digital cultural applications. We've seen already many examples today. The penetration of mobile technologies in the cultural heritage sector has created novel opportunities for combining existing digital assets with geospatial technologies. QR codes and augmented heritage content are increasingly used in the tourism industry through the creation of virtual heritage tours and cultural routes. The creation of these enhanced or digital experiences attracts new audiences through the addition of new layers of information and social interaction. Cultural heritage is made immersive and engaging, and possibly more attractive to the digital natives of today. During the development of mapping ancient Athens, the initial core of geospatial data collection on the ancient walls of Athens was employed in the development of Walk-the-Wall Athens, a bilingual, location-based mobile application for smartphones and tablets. The respective app linked 35 points of interest in a route around the historical center of Athens. The visitor is guided to approach available points of interest and access information about the linked wall parts in textual or audio mode, alongside additional visual content. In another example of Thessaloniki, as part of the NEAR project and the European Cultural Heritage Days in 2016, 7 hidden and therefore functionally invisible archaeological sites were selected to showcase the use of new tech for the urban heritage. QR code posters at site locations directed the visitor onto a website with basic information about its case. The main targeting of the event was to encourage the public gain personal experiences, stories, and memories in relation to the invisible past of the city, and express this through words and images onto social media. Going back to Athens, the combination of geospatial technologies and 3D modeling has made room for augmented mappings of cultural heritage. The Athens Time Walk allows the integration of 3D models into cultural routes. The user can experience 3D townscapes of the past during an on-site tour or use the platform off-site through the web. Either case, it showcases the quick shift in technological adoption by the cultural heritage sector and the opportunities for reusing data that are compiled as part from mapping applications. So in all examples presented, the crucial element is the actual content and the effort to prepare it. The content can be exploited in many ways, not just within the respective mapping platform. There have been a lot of cultural heritage mapping projects for various scales and thematic focus. As with many digital creations, not all of them are still with us. Functionality often diminishes over the years due to the constant development of software, internet services, and tools. In many cases, web mapping applications are the toll of administrative restructures that prevent the continuation of supporting teams. In case of outsourced development, funding usually stops at the end of the development cycle and is rarely directed to infrastructure maintenance or updating. In the digital realm, software applications are destined to die, but their death can be delayed, and they need not take the informational content with them. If the content is secure, all applications may be revamped easier into new ones and may be even more relevant and useful than the originals. As an example, Digital Crete has been a mapping application developed by the Institute of Mediterranean Studies to act as a platform for accessing and combining several spatial datasets that include geographic, environmental, cultural heritage, and historical content. The platform received its latest upgrade before 2010 and was accessible using the latest ArcGIS server infrastructure until 2020, the latest. Ever since, it is offline, and the wealth of material has been inaccessible. Relaunching using present technologies would possibly require re-engineering the entire platform and migrating the content. All these bring us into some important realizations. First of all, cultural heritage mapping can be a continuous or never-ending process that requires the curation of both content and digital infrastructure. Although we often think of the content as linked to its web platform, in practice, it holds great potential and can be reused and remixed into new ideas and outputs. However, in many cases, the content in cultural heritage mapping platforms is accessible, but practically unavailable or downloadable for further use. In the past few years, the open dissemination of cultural heritage data has been increasingly advocated as part of the greater movement of open science. Open science defines a new approach to the scientific process to make the primary outputs of publicly funded research results and supporting data publicly available in digital format with minimal restriction. Towards that end, a very important notion are the FAIR data that were mentioned in the beginning of the day. FAIR denotes data that are findable, accessible, interoperable, and reusable, encouraging developers to consider data stewardship issues such as data provenance, semantic interoperability, and data licensing from the beginning of their mapping endeavor. Very recently, in the context of two large European projects, the harvesting of geospatial cultural data has been explored. The Ariadne Plus project tries to bring together in a single searchable aggregator archaeological data collections from different countries and organizations. Within this project, a group of experts surveyed and registered several online geospatial archaeological data services with the prospect of creating an integrated catalog of services. The report manifests the difficulties in geospatial data integration and points to the following reasons: a low level of awareness of existing standards for geodata exchange and presentation, a low level of spatial data standardization, and a persistence of offline storage, a focus on building custom-made WebGIS applications to present archaeological data that do not include provisions for machine-based dissemination or use, licensing barriers to sharing and publishing archaeological data, and finally, the requirement of advanced skills to create and use OpenGIS compatible geospatial services, something that, as we saw in the morning, lacks in current higher education archaeological curriculum. SEADA comprises a research network of archaeologists and digital specialists working together to secure the future of archaeological data across Europe and beyond. In an effort to survey the reuse potential of available archaeological data, a user experience survey has been prepared and is open until the 26th of April. The participants can select a data provider platform and add feedback on the easiness in locating, accessing, and reusing its content. I invite all of you who have tried to search for available geospatial archaeological data online to take this survey. To sum up, mapping cultural heritage requires significant effort from many people with different backgrounds. This effort can last for long, as there are no limits to building up digital content. In doing so, a number of opportunities open up for extending the scope of these attempts, foregrounding new questions and research avenues, and creating spin-off apps for different audiences. However, there are limits to the longevity of the web GIS infrastructures, and in many cases, becoming outdated has severe effects on the underlying content. We need to understand that datafication and content curation go together, and that open data provisions at an early stage can benefit dissemination, foster preservation, and create surplus value by allowing third parties and the wider audience to engage and reuse the map content. Thank you.